Hello and welcome. My name is Alex Bolotnikov and I'm a software developer, game developer, used to work as a technical lead. And this is video where I want to show you how I create a simple PixiJS project template that I can use in game development and create games with that template as a foundation of the game. So this video has a text version available at gamedev.land. This is my website, and here you can open the Creating PixiJS project template, and here is the full documentation which you can follow, and this can be good addition for that video. By the way, that text also contains useful links, all the URLs of used materials for creating this lecture, so feel free to use it and follow it, this text also. And one note more, this is a briefly overview of tutorial where I create project template, but I'm not going to write all source code from scratch. I will just get these blocks of code that I have already prepared and that's available in this documentation, and I will use these blocks of code, paste it in the project step by step, and show you how it works, and we will discuss all these lines of code. And if you want to get more detailed explanation, you can visit my course based on this video and this text. And in that course we have separate lessons where we are going to create this template step by step with detailed explanations, and we go in depth in discussing more details there. But here is just quick, simple overview, briefly overview of what we're gonna create a template. So okay, let's start. And as I already said several times, our goal in this video is to develop a simple project template that we will use as a foundation for all our future projects. So we will create some common shared code that we will include in every game we will develop, and this code will be the same for every project. We can use it, and the idea is that we write the common code once, and then we will use it multiple times in every game, and we don't need to rewrite the common functionality here. So let's start with discussing the functionality that we want to see in this template. So there are basically three items that we need to discuss. First of all, this template should allows us to create a PIXI application and actually launch it. That's the start the game. This template should allows us to load resources and render loaded resources in the game. And finally, this template can contain code for management purposes. For example, we can create several common managers of our future games, like scenes manager, states manager, animations manager, sound, screen manager, and so on and so forth. And the idea is these managers should be available globally in every game, and that code should be also included in the template that we're gonna develop right now. Okay, now let's start with taking the empty project structure that I have already prepared, and that structure is available in the initial branch. So first of all, you can take this from the URL from the text version of this video, which is on gamedev.land PIXI project template. Here's the URL, and just open this initial branch. So I should make note one more time that that's not the main branch, this is initial branch, and the initial branch contains just the empty structure with no source code that we will develop further in this video. So let me just download it as zip, and I click download zip, and it should start downloading, and this is downloaded in downloads folder. So just extract the zip, and I can open my Visual Studio Code, and I'm working in Visual Studio Code, as you see. Just drag this project in Visual Studio, and here's the structure that we will use, and we will continue work with that structure. So what do we see here? Let's start from the index.html file, and this is a HTML template that will contain the final JavaScript code after the game is built. So right now there is no JavaScript code included in that file, and that's okay, that's totally normal, because this file is just a template that used to create the final HTML after the project will be built with the Webpack, and Webpack will import the final JavaScript in that file. So right now there is some CSS styles that we use for body tag and canvas tag. So we set background black color to body, and we create canvas, and we set the canvas position to be in the center of the screen. So like that property is used for making canvas be in the center of the screen. So, and as you see, there is no canvas element right now in the body tag, and that's also totally fine, because we will create canvas later in this video, and we will do it automatically by calling the PIXI library. So we should not create it manually here. Well, we can do it, but we will do it programmatically later. Okay, so let's go further, and let's open package.json file, and here is the configuration of our project and all of settings and dependencies we see here. So the main dependencies are GSAP library, which is used for animations, and PixiJS is used for rendering. So in our tutorial text version there is all documentation. This in useful links section we can open the GSAP to look at the official website of GSAP library, which is used for animations. Here's the documentation page, so feel free to investigate and research what is that and how we can use it, and we will also discuss it in later videos in when we will create some games using our template. So for now just leave it here. And the next is PIXI. Of course, we will create template over PIXI engine, and we will use PixiJS for rendering images and so on. And also we have development dependencies that are Babel and Webpack mainly. The idea is Webpack and Babel are used for build project, and so here if we can open these URLs from useful links. The webpack.js.org is bundle your assets in scripts, so it's just like a bundler. We have some source code. Using Webpack we create a bundled version of our project that can be used in production, and Babel is a compiler, JavaScript compiler, that compiles our top level JavaScript code to a lower level that could be understood by the all browsers. So the browser compatible JavaScript code we see in the output. So we use a combination of Babel and Webpack to create minified bundled version of our project for production. So that's the package.json is. There are also a script stack that shows us what commands can we use in the template, but we will talk about this a little bit more later. And we also have the src folder with the scripts folder and the index.js in it, which is empty right now, and that is an entry point of our application, which starts the JavaScript code here. We can also create some more folders right now. So let me create sprites folder for storing the assets, images assets. Let me create new folder and call it sounds for storing the audio assets. And into the scripts folder we can put also the game folder and a system folder. And that's how it works. So the system folder is should contain the common system code that is the same for all games we will develop. So that's basically is the source code of our template. So like in core code, shared code, or engine. So the all common code should be located here. And that folder game is a code of the game itself. It's unique for each project, and it should be separated from this system code. Okay, so now let's talk about the commands that we saw in the package.json. So first of all, we should install all the dependencies that we see in package.json. We can do it by opening the terminal, and here I can hit npm I that stands for npm install, and that's how I can install all the dependencies that are listed in dependencies block and dev dependencies block. After the command finished, I should see a new folder in the project structure that's Node modules. And by the way, this folder is excluded from the git, which we see in git ignore file. So that means that we have successfully installed all dependencies listed in package.json. Okay, and now let's talk about these two commands. As we see here, we have two ways for running the webpack. So let's first talk about the start. As you see, the start command starts the application with the webpack dev server and the base configuration that's located in webpack folder in base.js file. So we also have the webpack folder, and we see two files here, the base.js and the prod.js. And the base.js, as you see, that's the configuration of webpack that's used for development build. The development build can be started by running npm start. So npm start will run the webpack dev server, which uses the webpack base.js configuration, which is set for development purposes. And also this is the core configuration that's used by the production also, but the production also uses some more configurations that described in prod.js. So what should you know? We will not modify these files. Let's just leave this code, this configuration as it is, and we just should understand that this is two files for webpack config. The base is for development purposes and the prod for release or production build. And when we hit npm start, we are running webpack with dev server that automatically opens, make a build and opens it in the browser in real time. So here we see in log webpack dev server that it created a server and started the local server, and it's available by open in browser localhost 8080. And here we see the black screen, and that's totally fine because we know that our index.html has a CSS styles for body background color is black. So that's what we expect to see. And if I inspect this element, I see that head is containing some script that's not in the template, and that's fine because we just hit the npm start, which make a development build, and this is actually the development build. opened via local server. Okay, so we also have a build command that can be run with npm run build, and this command creates a production build. And as we see here, npm run build starts the webpack tool with the configuration in webpack prod.js, and prod.js also uses base.js, but also includes some more properties, not only the properties that are used in base, but we use mode production, we use output file name, and so on and so forth. And what is the result of running npm run build command? The result is actually dist folder with the bundled elements. So the dist folder now contains all the production code, all the assets that can be just uploaded to production server and used there. So here we see the index.html. That's not exactly the same with the template HTML. It's minified bundled HTML that also included JavaScript, which is located in bundle min.js file, which is now empty, and that's totally fine because in our sources, in our scripts, index.js is also empty. So there is no JavaScript code that we wrote, so there is no JavaScript code in production build right now, but we will work on it. So now we can finally start to write some code, and we will start with creating the main application class. Let's go to src scripts system, and let me create here a new file, and I will call this file app.js, and this is the main class of the application. And let me just copy this line of code. By the way, I will show you once again where I take the code. The code is in the text version of this video, which is in GameDevLand PIXI project template. And here I will just take this code, and in the future I will take the code blocks from this document too, and we will discuss these lines of code. So I will recall that we also will have a step-by-step detailed guides, detailed lessons where I write the code from scratch, but there's a briefly overview where we will just discuss the code. So what do we do here in app.js? First we import the PIXI library from PixiJS library, and we create the application class and describe the run method, which should start the game. This method received the one parameter, which is config of the game, and we set this parameter to inner property of the application class. And then we create the PIXI application, instance of PIXI application with the parameter resize to window. And then we attach the view property of created application object to body element, which means that this property should be HTML element, right? So let us first talk about the PIXI application. And the PIXI application actually creates this class creates a new PixiJS application. So we can research the documentation to get more details about that class, and for now we just take a note that we pass the parameter for resizing the created application to make it fit the entire window, and then we appending the view property to body element of our document. So now we should go to the entry point, which is index.js, and we can import a created system app class and run it. So we call run method here, and we will not pass the config right now, we do it later, so the config should be undefined. And we know that we can check our functionality by calling it npm start, like npm start, and that should open the dev server. and there is no errors here, which means all's fine. And now we can talk about these lines in more details. So let me just console.log this.app, and you see that this app is instance of PIXI application, which is available at PIXI. So you can find more details about this in PIXI application documentation. So this class provides us functionality for creating the and using all PIXI application opportunities. So this is a kind of API that we will use for creating our game. And what we want to look at is this app view. What is a view? And as you see, it's just a canvas element, so that we didn't include in index.html manually. And now, after creating the PIXI application, we have the canvas element in this.app.view, and that's why we appending this element as a child to body HTML of our document. So this app view is just a canvas that we can include in document body. Okay, let's move on, and let us create a loader for our assets. And before we create a new loader class, let's imagine what functionality do we need from the loader. So in other words, let's just describe the loader interface and use it right now in the run method, and then we will implement that interface. So we can imagine that we have some loader class, and we should call the preload method to preload all the assets we used in the game. And then, after all resources are successfully preloaded, we can start the game by calling the start method. So since we calling the start method, let us add this method in the application class. And let us create the loader class as we described here, because there is no such a class right now. So let me just create a new file in system folder, call this file loader, and I take the code for loader, and I describe the preload method here. So we assume that the loader should have the preload method which returns promise, and then we should call the application start. Okay, so for now it's just empty method that returns empty promise, and here are some fields that we should discuss. First of all, the loader receives two parameters in the constructor. The first parameter is some kind of loader. What is the loader is? So we take this loader from this.app, which is an instance of PIXI application, as we talked a minute earlier. So let's take a look. What is the this.app.loader? And here we see that the loader is an instance of PIXI loader class. So yeah, we have a PIXI.loader, which we can read about at PIXI loader documentation, and the URL is always in the useful links in our project template page in documentation. And this page describes how we should work with PIXI loader. And yes, we create our own custom loader that uses PIXI loader. That's right, that's what we do. So the first parameter is PIXI loader, and we pass this loader to our custom loader. And the second parameter is magic config that we pass to the loader from the application. So this is the actually application config, right? And we set the loader to the property loader, config to the property config, and some resources is equal to empty object. And this resources is we will set the loaded resources into that object later, after the resources will be preloaded in here in this method. The config is taken from the we take this config from the application, and we receive this config from the entry point right here from index.js, but there is no config here. And basically the config is used for the list of all resources to load. So this config is a list of all resources that we want to load. And how should we get this list? The question is, how should we get the list of all resources? So the resources, let's say we have some sprites in sprites folder, and by the way, let me actually open the sprite that I used in final source code. Let me open this page, and here in src sprites I see the bg.png, which is used for rendering background. So let me just save image as bg in download folder, and let me get this file bg.png and paste it in PIXI project template src sprites here. And now I see in the project structure in VS Code that file, yes, in sprites, bg.png. Okay, now we have bg.png, which we will use to render background, right? And let's say we want to load this using the loader, the PIXI loader, our custom loader. How should we do that? First of all, we should receive it as a file to load, right? And the list of resources to load will be unique for each game, right? So we need to define the resource config separately from the common code. So outside the system folder and in game folder. So let me create new file called config, and here I will create a common config for the particular game. So for now we just specify config as an object with the parameters that's used in every game. So the game should use the list of resources to load, and we should create the loader property, which actually will receive the list of resources to load. And how can we get that list? So we want to automatically get the entire list of resources to load from a given folder, and we give the folder sprites as you see here, and we're using some functionality of require context, which is provided by Webpack. And let me show you, if we want to get more information about it, it's available in Webpack require context page. So require context basically allows us to pass a directory, as we see here. We pass a directory, the directory to parameter of require context function, which is sprites, and the Webpack will search for files in that directory, and it will use the pattern that we provided here. And using this functionality, we can search for all files in the given folder with a given pattern and get the list of these resources. So, and we should actually process the collected list, and we should use some helper method that we need to implement right now. And in system folder, let me create a tools class, and I can implement some helper method that can take the require context result as a parameter and work with it, and as output I will receive an array of files which I want to load. So let's check how it works. So first of all, we need to update the entry point, and here we should import the config from particular game and pass the parameter into the run method. And let me check the what's in this config right now. So here we see the config loader that contains some array of files we need to load, and this is array of objects, and every object in that array has key property, which stands for path of the file with its file name and the data of the file, which is module, webpack module. So that's what we need, and we let's actually pass as a second parameter to loader not the global config of the application, but just the loader config, right? So in the config we have the loader property created specially for the loader. So right here we should pass the loader config, not the global config, just the loader config. So we should import the loader class here. And now we have successfully imported the loader from our custom loader file, and we create a config. Okay, so let's move on. Now we finally can implement this preload method, and we should do two steps in that method. First of all, we should add all required resources to load in the PIXI loader list. And finally, we should call the load method to load the resources. There are two steps that we should implement. And here we see that the documentation about PIXI loader says that we should add all resources with the add method and then load the resources with load method. That's what we should do right now. And let me implement the preload method. I will do it in the following way. So I know that in the config, well, yeah, here I used the config.loader. Well, yes, let us actually pass it just this global config, and that's how we can make it works. So in the config of the loader, here we have all the resources we need to load, and we go in a loop with each asset we need to load. We add each asset to the loader, PIXI loader, and use the add method for it. And finally, when all resources added to the PIXI loader here, we call this .loader load to make it finally happens, to load the resources, to start the loading. And this method, PIXI loader load, this method takes a callback function as a parameter, and this callback function takes two parameters. The first parameter is actually the loader itself, and the second parameter is the loaded resources. So basically, we are passing the callback function to PIXI loader load method, and that function will be called after all resources will be loaded, and all resources that we have added with the add method here. So we know that all loaded resources is available in the second parameter of this callback function, so we just assign this parameter to this .resources, which is the field of our custom loader, which is empty object at the beginning, and now after resources loaded, this resources will be set to this resources field, and that's how we can access them later in the project. And finally, we will launch the game. So now let's go to the application class and open the application class, and let's first of all let's console.log start to make sure that we are calling the start method with no errors. And yes, we have the start log message and there is no errors, and here in the start method, we know that this method is called after all resources are loaded. So here we should get access to all of the resources. And where is the resources? The resources in the resources property of the loader right now. So we can log them out, and we can log them by calling this.loader.resources and check how it works. Yes, so we have a bg resource with a bg key, and this is just an instance of loader resource file, right? So we can use it to make the sprites on the scene, and let's actually make the scene right now in the start method. So here how we can make the scene, and well, yeah, we could instantiate the scene by calling some class right here, and this scene is equal to new game scene. And where should we get the game scene? We should import it, and where from we should import the scene, and the game scene is referred to the game code, so we should import it from actually game scene. But there's a problem. So the problem is we want to system code not to rely on game code. So the idea is that share the code, this common system code in the system folder should be unrelated and should not be dependent on the game code in the game folder. On the other hand, the game code could rely on the system code, but system code must not rely on the game code. So that's why we should not create some imports from game here, and that's why we are doing like instantiating the game scene, the start scene from the config. And we know that we created config in the game that's specific for the game itself, and here are the all properties that we want to make configurable for the appropriate game. And here we can specify a parameter start scene, and this scene should be some class in a game folder, and we can import this class here because we are now in config, which is in the game folder. So let me create a new file, and I call this file game here, and what I should do is create some game class, just some regular game class. And as I said earlier, the game code could rely on application and should rely on application code, and that's why I can import application in game. But the application code should not rely on game. That's why we create the game as a parameter in config. And what do we do here? We just create a PIXI container and assign it to the container field of the game class. And here we finally instantiating the start scene from the config, and start scene in the config is the game we just created, this just class. And finally we assign in the container that we created here to the app stage container. And the idea here is that the app is the, as we know, is PIXI application instance of PIXI application class, this object, and this object has a global general main container that should includes every renderable object. So the idea is we create scene, and scene should have some container that contains all scene elements like sprites, assets, and so on. And we assign this scene container with all scene elements. So this container should contains all scene elements, and this scene container is a child of the global PIXI container, which is accessible in PIXI application stage property. Okay, so that's how we can start the game, and let us check that we actually in the game constructor, console log, and hello game. Let me check. Yeah, Great, so we see the log message, so we know that we are in the game constructor. And finally, what should we do now is let us render the background image. And to render sprites, we need first to implement some helper methods in the core code and especially in the application class. So here I need some more methods to create an opportunity to create sprites on this game scenes. So I added two methods, res and sprite, and so as we know, all loaded resources are available in our custom loader, in the custom loader resources field, and let me just recall that here this field is, and we set all loaded resources in the preload method after all resources loaded here in the callback. So, and in application, we just checked that we have loaded background in that property. We can access it by key, and we should access the texture property now. That's how we can get a resource texture. And what should we do next? Next, we should take this texture of the resource with the given key and pass it this texture as a parameter to PIXI sprite property. So in the documents we can read actually about the PIXI sprite, right? And as we see, we need to pass the texture, right, to the sprite, and we have this texture in loaded resources, and we can access loaded resource by key, get texture, and assign it to the PIXI sprite. So creating an instance of PIXI sprite is creating a sprite in a scene, and that's the way that helps us not to write every time new PIXI sprite with a given texture, but now we can just call up.sprite, that's all. And that's how we can create a background on our game scene. So open the game scene, create background method, and that's what I was talking about. So instead of writing every time new PIXI sprite, new PIXI sprite, new texture, something like that, we just call an up.sprite with a given key, and that's already gives us the background PIXI sprite instance. That's great. Then we will change dimensions of background to make it fit the entire screen, and as we talked a minute ago, we should assign all the elements on the scene to the scene's container, which we created in the constructor. And we know that this container is assigned to the global PIXI container, which is in this.app.stage, right? So now we assume that after calling the sprite, we create an instance of PIXI sprite and assign it to the scene container, so we should see it on the screen, right? And we don't see it because I didn't call create background, and now there it is. Okay, great. So we will improve this code later and add some more functionality like managers, management of scenes, states, and so on and so forth. Read the documentation of this tutorial, follow the documentation of PIXI, and feel free to use all this information, or you can check out my courses with step-by-step guides with a detailed explanation in each step, and I see you in the next videos. Bye bye.